Hey guys, today I'm going to be working through an AS Math Pure paper. This is paper 11 from May-June 2010. So this video is really to show you how I would approach these questions. So I'll just be, explaining it, talking through my way of thinking about it and my way of working through it. So if you have any questions or anything at the end, then please leave them in the comments below and I'll definitely do another video addressing those questions, going over particular topics in detail if you guys need help with that. So let's get started. So here's question 1. It's easy to see that this is a trigonometry question. Now when I see a question that looks like this where they give us, one of the tans or sines or coses, and we need to find a bunch of the other ones, my first step is always just to draw a triangle, a right angle triangle, so that I can visualize what's going on. Now if tan x equals k, we know that tan equals, tan is opposite over adjacent, right? So let's just label one of these angles x. Now the opposite to that would be k over 1. That's how we would get tan x equals k. So now that we've labeled that, we can find what the hypotenuse would be, because that usually comes in handy as well. So that's using Pythagoras theorem, and we get this. Cool. So now the first question they're asking is find tan pi minus x. Okay, so for this, we can't actually use the triangle we just drew. We need the graph. So if you draw the graph, it makes it a lot easier to find pi minus x on a tan graph. So the graph looks something like this, where this is pi over 2, and this is pi, and this is 0. So if we call this x here, tan x is k, and we know that. So pi minus x would be around here, and this would be minus k. So we've got an answer now. It's tan pi minus x equals minus k. So I got that from the graph. Now for part 2. Find tan pi over 2 minus x. Cool, so this is where the triangle comes in. Since it's a right angle triangle, this angle and this angle would add up to 90. And we know that 90 is pi over 2. So that equals 90 degrees. And this angle would be 90 minus x, which means we can call it pi over 2 minus x. So now all we need to do is find the tan for that angle. So remember, the tangent would be opposite. So tan opposite over adjacent. So if this is the angle we're looking for, the opposite is here and the adjacent is here. So we would write tan pi over 2 minus x equals 1 over k. That's part 2 done. For the last part, sine x. So we're just finding the sine of this angle now. Sine is always opposite over hypotenuse. So the opposite is k, and the hypotenuse is this. So we would just write sine x equals k over k squared plus 1. There we go. Okay, now for question 2. Find the first 3 terms in the expansion of this in descending powers of x. So that means we want the highest power of x to come first, and we want it to go lower and lower. So we can just start with 5c0. Obviously the 2x is the higher power out of these two, right? So we're going to give that the power of 5, 2x to the power of 5, and minus 3x would be to the power of 0. And then plus 5c1, 2x to the power of 4 minus 3 over x to the power of 1 plus 5c2, 2x to the power of 3 minus 3 over x to the power of 2. So those are our first three terms, and we just want to use our calculator now. Type in 5c0. Oh yeah, obviously that's 1. So this is 1, this is 1. So we've got 32x5 here, plus, so this is going to be 5 times 16, which is 80, times 3, going to be 240. Also there's a minus there, so this is going to be a minus because of that. Minus 240. And then we've got 4 x's here, that cancels out with 1 x there. So we've got x cubed. And 5c2, that's the last term, 5c2. I'm going to type it into my calculator. That's 10. So 10, so this is 10. This is going to be 8. So 10 times 8 times, this is going to be 9. So that's 720 actually. So 720. And then how many x's do we have here? 3 and 2 on the bottom there, so that cancels out to just give us 1x. 720x. So there are our first three terms for this. Now for part 2. Hence find the coefficient of x in this expansion. Okie dokie. So basically you can see that the equation in the top part is the same as the one here. So they made us expand it a little bit so that we can use this in this. So what I'm going to do is just write out 1 plus 2 over x squared. And then I'm going to write this out in the second bracket. 32x to the power of 5 minus 240x cubed plus 720x. And we want to find the coefficient of x. So now I'm going to look for what from this bracket multiplies with this bracket to give us something that ends in just x. So for example, 1 times, 32x to the power of 5 would give us something x to the power of 5, and we don't want that. So we're going to times the 1 with the 720x. So usually I just like to write, x, and I just do this. And then I just write 720x, the first one, and now what can this multiply with to give us x? There's x squared on the bottom, so if we multiply it with the x cubed, that'll give us an x. So that'll be minus 480x. Yep, so 720x minus 480x. And that gives us 720 minus 480, 240. 240x. So our x coefficient is is 240. Cool. So on to question 3 now. We're told that the 9th term of the arithmetic progression is 22 and the sum of the first 4 terms is 49. So all we're going to do here is use the formulas to get some equations down. So the first formula is this, a plus n minus 1d. This is the general formula for any term in an arithmetic sequence. And because we know the 9th term, we're going to put 9 in place of n. and that's going to be a plus n minus 1. 9 minus 1 is 8, so 8d. And we know that that's 22 because they tell us here. Now using the second part of the question, the sum formula is n over 2 bracket 2a plus n minus 1d. Now the more questions you do, the easier these formulas will get for you to remember and just use whenever you need them. So we've got S4 now because they've told us the sum of the first 4 terms is 49. So we're going to substitute 4 in place of n. 4 divided by 2 is 2. 2a plus 4 minus 1 is 3, so 3d. And this is going to equal 49. Now we've got two equations here, 1 and 2, and we're going to simultaneously solve them. So I'm going to rearrange this to make a the subject, because I think that's the easiest way to do it. So it'll be 22 minus 8d. And I'm going to substitute this a into here. So that will be, actually first I'm going to simplify this. So 4a plus 6d equals 49. And then I'm going to substitute this a in here. So 22 minus 8d plus 6d equals 49. That'll be 88 minus 32d plus 6d equals 49. And then we'll have minus 26d equals minus 39. d equals minus 39 over minus 26, which is 3 over 2. Okay, so now that we have a value for d, we're going to substitute that back into our equation for a. So a equals 22 minus 8 times 3 over 2. So that's 22 minus 8 divided by 2 is 4 times 3 is 12, so a equals 10. So we have a equals 10 and d equals 3 over 2. So that's our answer for 3, part 1. And we can do 3, part 2 as well. It says, the nth term of the progression is 46. Find the value of n. So let's just label this part I. And then over here, actually I'll change the color for you. I. The nth term of the progression is 46. Find the value of n. Okay, cool. So now that we know a and d, when we write Tn equals a plus n minus 1d, we actually have values for a and d here, so we're going to put those in. So that'll be 10 plus n minus 1 times 3 over 2, actually, plus 3 over 2 n minus 1 equals, what was it, equals 46. So now we need to find a value for n from this equation. Shouldn't be too hard. Let's take the 10 over to the other side, so 3 over 2 n minus 1 equals 36. N minus 1 equals 36 times 2 over 3, that's 12 times 2 is 24, so n minus 1 equals 24. You can also get this by typing this into your calculator if you don't know how to do that in your head. Or if you want me to do a separate video on it or anything, just let me know. And n equals 25. All done with question 3. Okay, so now on to question 4. The diagram shows this curve and this line. Find the area of the shaded region. Okay, so anytime you're asked to find the area of a shaded region, given, a graph and some equations, It's usually an integration question. We know what we need to do, which is find the x values here. We need to find these two values, and then integrate with these two values as the limit. So the first thing to do would be find those values, and those values are the intersection points of this graph and this line. So how do you find intersection points? You just equate them. So x squared, 6x minus x squared equals 5. I'm just going to take everything to the same side and make it positive. So I'm going to take everything to this side. So x squared minus 6x plus 5 equals 0. Factorize x minus 5, x minus 1 equals 0, x equals 1 and 5. So now we know that these two values here are x equals 1 and x equals 5. So we're going to be integrating between those two values. Okay, so now if we integrate just this graph between these two values, this is what we're going to get. We're going to get this whole area. So what we can do is we can figure that out, and then we can just subtract the area of the rectangle from it in the end. So let's do that. Let's find the area under the graph for those two values. So A under graph equals integrating 6x minus x squared, put dx there, and we're doing it from 5 to 1. So when you integrate, you always add 1 to the power and divide by the new power. So this is going to be 6x squared over 2. And for x squared as well, add 1 to the power, so that's going to be x cubed. So x cubed and divide by the new power over 3. So 5, 1, and now we're going to substitute. So when you're integrating with limits, always just do the integration first in square brackets and put the limits on the outside, and then you can substitute it. So now we're going to substitute. I'm just going to change this 6 over 2 to a 3x squared because that will make it so much easier. Alright, so we're going to substitute the 5 in first. So 5 squared is going to be 25, 3 times 25 is going to be 75. 75 minus 5 cubed is 125. So 125 divided by 3. I don't think we can do that, so I'm just going to write it like this. Cool. And then minus, and now I'm going to put a bracket because you always have to minus the limit on the bottom. So we're just going to substitute the limit on the bottom. Now we're going to substitute the 1 in. That's going to be 3 minus 1 over 3. So 75 minus 125 over 3 minus 3 take away 1 over 3 is going to be 2 2/3. So 2 over 3, but, we can change that up to make it 8 over 3. 75. You can totally type this into your calculator, by the way. I just enjoy working in my head and on paper. 125 minus 8 is 117 over 3. And this is divisible by 3, so 17. Okay, now I'm going to use my calculator. So it's 39. So that's 75 minus 39, which is 36. So that's the area under the graph, so that's this whole area. So now what we're going to do is find the area of the rectangle. So we're just going to find this blue area. Now this shouldn't be too hard because it's just length times width. So the length is 4 because it's from 1 to 5. So the length is 4 and the width is 5 because y equals 5 at this line. So 4 times 5 is 20. Cool. So then we can write A shaded equals 36 minus 20, which is 16. Cool. Okay, now for question 5. We have a function. It's a trigonometric function. We know that because of the sine and the cos. They want us to express fx in the form a plus b cos squared x, stating the values of a and b. All right. So this is going to be using the formula sine squared x plus cos squared x equals 1. So we're going to be using this in some way. All right, let's give this a go. Okay, so fx, part I, fx equals 2 sine squared x minus 3 cos squared x, which is equal to, so we can see that in this we don't have any sine squared, so that means that they're probably converting this into a cos squared form. So that's going to be 2, 1 minus cos squared x, because sine squared is equivalent to 1 minus cos squared from that formula that I showed you earlier. So we've got that, and then the 3 cos squared just stays the same. If we expand this out, 2 minus 2 cos squared x minus 3 cos squared x equals 2 minus 5 cos squared x. So a here is 2 and b is minus 5. And you have to put the minus in because they've given b as a positive thing there. So that's part 1 done. Okay, so for part 2 of the question, we need to find the least and greatest values of fx. So let's just write down fx over here again. X equals 2 minus 5 cos squared x. So to find the highest value for fx, we need to do 2 minus, we need to find what the smallest value of this can possibly be, because we want to take away the smallest value to get the overall highest value. So it's a square number, right? Cos x is being squared, which means it's either going to be positive or 0, which means the smallest value you can subtract would be 0. And 5 times 0 is just 0, so the highest value would be 2. Now for the lowest value, we need to look at what the highest value of cos squared x can be. If you know anything about the graph, the highest value is always 1 for cos x, and 1 squared is just 1. So 5 times 1 is 5. So you'd go 2 take away 5 times 1, which is just 2 take away 5, which is negative 3. So that's the lowest value, and 2 is the highest value. And that is how you do part 2. And now finally for part 3, we need to solve the equation fx plus 1 equals 0. So fx plus 1 equals 0, we know what fx is. It's 2 minus 5 cos squared x. If we put plus 1 equals 0. And we need to solve this for x. So we just need to simplify it and figure it out. 5 cos squared x equals minus 5 cos squared x plus 3 equals 0. Cos squared x equals 3 over 5. Cos x equals plus or minus root 3 over 5. And then x equals cos inverse root 3 over 5 and cos inverse minus root 3 over 5. Oop, this root comes over the whole thing. So now I'm going to use my calculator to find the answers to this. And let's just check if we need it in degrees or in radians. Okay, so you can tell from the question, because I've got a pi here for the range of x, that we need to be using radians. So make sure that you change your calculator into radian format. If it's in degrees, you'll probably lose a couple of marks. So for the positive one, when I type this into my calculator, I get x equals 0.685 radians. This is to 3 significant figures. So I actually got 0.684719, blah, blah, blah. But, you know, Cambridge usually likes us to write it in 3 significant figures. And since it was 6847, we're going to round this up to 5 for 3 significant figures. 0.685, that's for the positive one. And when you type in negative, when you type this into the calculator, I got 2.46, also to 3 significant figures. And you can put that in brackets here so they know that we've rounded it. So that is question 5 done. A bit of a long one here, 3 parts. But good job everyone if you followed that. It was a bit complicated, so if you have any questions, just leave them in the comments below. Okay, question 6. So we've got a dy over dx equation. I like to just call this y dash when I work out stuff. So that's a gradient function, cool. And we've got a point, and we need to find the equation of the curve. Okay, so instantly, if you're given the gradient equation, if you're given y dash, and they tell you to find the equation of the actual curve, you know that that's integration. Going from a gradient equation to an actual curve equation is always integration. So that's what we've got to do for part 1. So we're going to integrate 3x to the power of a half minus 6 dx equals, add 1 to the power, so the power is going to be 3 over 2, so 3x to the power of 3 over 2, and then divide by the new power. So we're going to times by 2 over 3. The reason I do that is because when you divide by 3 over 2, that's the same as timesing by 2 over 3. So 2 over 3 times this. Again, for the 6, add 1 to the power, divide by the new power. The new power is just 1 though, so we can just leave that as is. And now simplifying this, we get 2x 3 over 2 minus 6x. Okay. So this, oh, and we've got to write the plus c, can't forget that. Okay, so now that we've got an equation for y, we need to substitute our point in to figure out what plus c actually is so that we can get the actual equation. So our point is 9, 2. So using 9, 2. So 2 goes into y because that's the y coordinate, so 2 equals, and 9 is the x coordinate. So 2 times 9 to the power of 3 over 2. So the root of 9 is just 3, and 3 cubed is just 27. So 2 times 27, which is going to be just 54. Okay, and then minus 6 times 9 is 54 again. Oh, plus c. Okay, so then c is just equal to 2. So our final equation for our curve is 2x to the power of 3 over 2 minus 6x plus 2. That's part 1 done. Part 2, find the x-coordinate of the stationary point on the curve and determine the nature of the stationary point. Find the x-coordinate of the stationary point on the curve. Okay, so what is a stationary point? A stationary point is usually, some sort of a turning point. But the definition of a stationary point is that the gradient at the stationary point is 0. So y dash equals 0. So we do have a really easy way of finding this, especially because they gave us the gradient equation. They gave us this equation here. So we just need when the gradient equals 0. So we're just going to go y dash equals 3 root x minus 6 equals 0, and we're just going to find where this is true. So root x equals 6 over 3, which is just 2. So then x equals 2 squared, which is 4. So that's the x-coordinate of the stationary point. And how do we determine the nature of it? You have to double differentiate, find y dash dash. So y double dash is equal to, okay, I'm just going to change this to x to the power of half because I find that much easier to work with when you're differentiating. So 3 over 2x minus 1 over 2, and then the 6 disappears because it's a constant. Now when, oh, this is part 3, I was about to say. Oh no, it's not, it's just part 2. When x is equal to 4, y double dash equals 3 over 2 root 4, which is just 2, which is equal to 3 over 4, which is greater than 0. So if y double dash is greater than 0, that means the stationary point at x equals 4 is a minimum. So if it's greater than 0, if y double dash is greater than 0, we have a minimum. And if y double dash is less than 0, then it would be a maximum. But in this case, it's greater than, so we've got minimum. And that's how you do question 6. Okay, so question 7 now. We've got a part of this curve, crosses x-axis at A, and the y-axis at B. Cool. The normal to the curve at A crosses the y-axis at C. Okay. So a few things I get from this is that since this is on the x-axis, A's coordinates are going to be something and 0. And AC is normal to the curve, so that means this is a right angle. So whatever the gradient is for the curve here, AC is going to have a perpendicular gradient. Okay. So step 1 would be to find the x value of A. And how do we do that? We know it's on the x-axis, so that means y is going to equal 0, so we just substitute y is equal to 0 into here. So when y equals 0, you get 2 minus 18 over 2x plus 3 equals 0. 2x plus 3 minus 18 equals 0. 2x plus 3 equals 18 over 2, which is just 9. So 2x equals 6 and x equals 3. Cool. So A's coordinates are 3, 0. So let's just note that down here as well, because we're going to need to use that later. And the next thing we need to do is find the gradient of the curve at A. And we need to do that because we need the gradient of the normal at A. And we don't have anything to do with the normal yet. So we've got to find the gradient of the curve, and then we find the perpendicular gradient to that. So finding the gradient of the curve, you just need to differentiate the curve and substitute the value of A in. So differentiating y dash equals, so the first line I'm going to write is just reformatting y in a way that makes it easy for me to differentiate it. So this dash is just another symbol for differentiating. I like to use that because it's so much easier than writing dy over dx every time. So we're differentiating this. So the constant 2 disappears, and then we have minus 18 times minus 1, because the minus 1 comes to the front using chain rule. 2x plus 3 minus 2 because we take 1 off this power. And then you have to differentiate the inside of the bracket using chain rule, so that would be 2. Oh my gosh. So now we have 18, so this is going to be positive because there's 2 negatives, and then times 2 is 36. So we've got 36 over 2x plus 3 squared. So this is our y dash. This is our gradient function. At x equals 3, which is at a, y dash equals 36 over 2 times 3, which is 6, plus 3 squared, so 9 squared, which is 81, which is equal to 4 over 9. So this is our m tangent. So this is the gradient going this way on the curve, m 4 over 9, which means that the normal gradient, so m normal, which is MAC, is going to be the negative reciprocal of this. So negative reciprocal just means you put a negative and you flip it. So this is the gradient of AC. Okay, so now we've got a gradient for AC and we've got a point, A30. Now that we've got both of these things, we can find the equation of AC. Y equals mx plus c. I always like to start with the general equation of a line when I'm finding an equation. So we substitute in all the values, this and this, so that we can find c. So y equals 0, m is minus 9 over 4, x is 3, and then plus c. So c equals 27 over 4. Okay, so now that we have that, we can go back to y equals, substitute m, which is negative 9 over 4, and then x plus 27 over 4. If we multiply the whole thing by 4, you get 4y equals minus 9x plus 27, which is really close to what they're wanting. 9x plus 4y equals 27. And if we just rearrange this, bring the x to this side, you get exactly what they're after. So 9x plus 4y equals 27. And we are done with part 1. Now finding the length of BC. The length of BC. So, okay, to find the length of BC, all we need to do is find the coordinate of B and the coordinates of C, but we can do that because we already have the equation of AC, so that shouldn't be too hard. Actually, we already have the coordinate of C. It's 27 over 4. So we know that C is 27 over 4. We need to find what B is. And that should be easy enough because it's on the y-axis, which means that x equals 0. X equals 0 on the y-axis. So let's just substitute x equals 0 into our main equation. So finding B coordinate. So this 2x here would just become 0. So we've got 18 over 3, which is just 6. So y equals 2 minus 6, which is minus 4. So b's coordinates are 0 and -4. So if we look back up at the graph, we know now that b is -4. So we just want to find the distance between 27/4 and -4. It's going to be length BC equals 4 plus 27/4 is, I'm typing this into my calculator, 43/4. And the reason I used +4 here and not -4 is because we're looking for the length. So from this point to this point, you have a length of 4. And from this point to this point, you have a length of 27/4. So the total length from here to here is going to be 27/4 plus 4, which gives us 43/4. So that's question 7 fully completed. Okay, on to question 8. The diagram shows a triangle ABC in which A is 3 minus 2. Okay, they've put that in here. B is, yep. The gradients of AB, AC, and BC are these three respectively. Cool. Where M is a positive constant. Okay. Find the gradient of AB and deduce the value of M. So we want the gradient of AB, deduce the value of M. Okay, so they've given us the coordinates of A and B. So we can find the actual gradient, and from that we can just find M because they've given us what it is in M terms as well. So finding the gradient of AB, all you need to do is rise over 1. So we're always going to do the y difference minus the x difference. So MAB equals, so I'm going to start with B because the numbers are bigger. So 22 minus 2, so 22 plus 2, over, and then we're going to do the differences between the x, so x minus that x, so 15 minus 3 equals 24 over 12, which is 2. So that's the gradient of AB. And since they tell us in the question, they tell us that the gradient of AB is 2m. So that means 2m equals 2, which means m equals 1. So now we've got the value of m as well from part 1. So now that we've got that, let's do part 2. Find the coordinates of C. Okay. So I'm just going to rewrite the gradients down. So MAB equals 2, MAC, it says it's negative 2m, and since m is just 1, it's just going to be negative 2. And MBC is just 1. So to find the coordinates of C, I'm going to find the equations of AC and BC and equate them, because that'll give us the point of intersection, which is C. So let's find the equation of AC. So equation AC, okay, AC. Y equals mx plus c, again starting with the general equation. Y is going to be, okay, what's our A value again? 3 minus 2, okay. So A is 3 minus 2, B is 15, 22. Alright. So minus 2 equals, our gradient is also minus 2. Minus 2, our x value is 3 plus c. C equals 4. So our equation for AC is y equals, our m is minus 2x plus 4. So that's our AC equation. Now we need to find BC's equation. BC. Again, starting with the general equation, y equals mx plus c. Now we'll be using the BC gradient and point B to find the equation. So B's y value is 22, the gradient is 1, x value is 15 plus c. C equals 22 minus 15, which is 7. So y equals, m value is 1, so just x plus 7. So this is BC's equation. Now what do we want to do? We want to equate both this and this to find point C. So AC equals BC. X plus 7 equals minus 2x plus 4. 3x equals minus 3, x equals minus 1. And y equals, now we can substitute into either of these equations. I'm going to do BC because it looks easier. So if you substitute minus 1 into here, you get y equals 6. And if you want to double check that, you can put minus 1 into here as well, and we should get the same answer. Minus 2 times minus 1 is positive 2, plus 4 is 6. So we know that we've got the right value for C. So C is minus 1 and 6. That is part 2 done. Okay, now for part 3. The perpendicular bisector of AB meets BC at D. Oh my. Perpendicular bisector of AB. I don't like this purple, I'm going to change it to this. The perpendicular bisector of AB meets BC at D. Okay, so the perpendicular bisector would be halfway between A and B. So there must be an M here, which is, so MAB. Oh, so this is capital M, and it stands for midpoint. So the midpoint between A and B. So for the x values, you just have to find, whatever's right in the middle. So it's basically like finding the average. You go 15 plus 3 over 2. So that's 18 over 2, which is 9. And for y, same thing, 22 minus 2 over 2. So that's going to be 20 over 2, which is 10. So the midpoint is 9 and 10. So the perpendicular bisector goes through there. Something like that. And this is a right angle. And it meets BC at D here. Okay. We can find the gradient of our bisector line. Let's call the bisector line MD. So we can find the gradient of this line because it's just perpendicular to AB, and we've got the gradient of AB already. The gradient of AB is 2. So MAB equals 2, so M of MD is the negative reciprocal because it's perpendicular to AB. So negative 1 over 2. And what do we want to find? We want to find the coordinates of D. So you can see that this is a 4-mark question, so it is going to be a bit of work. I like to check that sometimes to, if it seems hard or if I'm going a really long way and it's only 2 marks, then I'll know that there must be an easier way to do it. This is 4 marks, so it does seem like a question with a lot of working. So what I'm going to do here is find the equation. Let's make this smaller. Find the equation of MD, and then I'm going to equate that to the equation of BC. Okay, so finding the equation of MD now. Y equals mx plus c. Our m is negative half. Our y is 10 and our x is 9. So we're just going to put all of that into here. So 10 equals negative half 9 plus c. C equals 10 plus 4 over 2. Oh, 9 over 2, 10 plus 9 over 2. Just typing that into the calculator because it's just faster. 29 over 2. So C equals 29 over 2. So then our equation for MD is y equals minus half x plus 29 over 2. Okay, now let's remember that. And we want to find the equation of BC next. I'm just going to take this down to the end of the page. Actually, I can just do it up here. So equation BC. We have the coordinates of C, right? Yep, negative 1 and 6. Okay. So C is negative 1, 6. We already have the gradient of BC because it's just 1. So m equals 1, and we've got a point. So y equals mx plus c. Substituting the point in, substituting the gradient in. 6 equals minus 1 plus c. C equals 7. So then y equals m is 1, so x plus 7. This is our BC equation. So now what we want to do, we have the equation for BC, and we have the equation for MD, and we're going to equate them to find point D. So we're going to do this equals this. And now I'm going to just copy it down at the bottom because we need more space. X plus 7 and half x minus half x plus 29 over 2. Okay. Minus half x plus 29 over 2 equals x plus 7. So this is equation MD equals BC. So we get 3 over 2x, so we're taking this over to this side and then flipping it. 3 over 2x equals 29 over 2 minus 7. I'm going to times everything by 2, it'll just make it easier. 3x equals 29 minus 14, 3x equals 15, x equals 5. And if x equals 5, then you can substitute it into either of these sides. You should get the same answer. For y equals 12. So our point D is 5 and 12. And let's just double check it on this side. So if x is 5, that'll be 5 over 2. 29 minus 5 is 24. Divided by 2 is 12. Yay, okay, gives us the same answer, which means we've got our values for D. And this is question 8. Okay, so now we've got the second to last question. It's a functions question. Function f is defined by this. Express f in the form ax minus b squared minus c. Okay, so this is completing the square. And you can see that they take out the 2 because, you've got the a here and just x inside. So that's the first thing we're going to do as well. So we've got fx equals 2x squared minus 12x plus 7. Let's take the 2 out. So 2x squared minus 6x. I'm going to leave the 7 as is because I just think it'll make it easier in the end. So now that we've got x squared minus 6x in here, we know that the inside bracket is just going to be x minus 3 squared because that's half of 6. So we're going to have 2x minus 3 squared minus 9 plus 7. Expanding the brackets slightly, expanding these bigger brackets, these outer ones, not the inner ones. So 2x minus 3 squared minus 18 plus 7 equals 2x minus 3 squared minus 11. And that's how you complete the square for this. The range of f. So we've got, now that we have it in completed square format, we can easily sketch it. So we've got our axes here. We know that the vertex is going to be 3, 11. So vertex is 3, 11. Well, 3, negative 11, sorry. We know it's a positive parabola, so 3, negative 11. It would be something like this. So this is going to be negative 11, and this is going to be 3. So the range of f is if x is greater than or equal to negative 11. So range is always referring to if, and if they ask you for a domain, which they might later, that's to do with the x values. But range is always associated with the y values. So we can see from this sketch that fx is always going to be greater than negative 11. Okay, find the set of values of x for which fx is less than 21. So that means that, if we have our graph here, something like this, here is 21. So what are the x values? These values where our fx is less than 21. So all we need to do for this is write fx down. So fx equals 2x minus 3 squared minus 11, and we want this to be less than 21. So just rearranging, trying to get x to be the subject here. 2x minus 3, I'm gonna make the pen a bit smaller, okay, minus 11, nope, okay, so let's take the 11 to the other side. So it's less than 32. We need a squared, okay. x minus 3 squared is less than 16. Okay, so now we've got something much easier to work with, and I'm going to sketch this graph. X minus 3 squared is less than 16. It's going to look something like this. I want it to be less than 16, so I'm just going to make this an equivalent thing for the moment, and x equals, oops, plus or minus 4. So x is going to equal 3 plus 4 and 3 minus 4. So x is going to equal 7 and 1. So we know that it's 1 here and 7 here, and we want it to be between these values because it's lower than. So that will be 1 is less than x, which is less than 7. And there's our values. Cool. Part 4. The function g is defined by gx equals 2x plus k. Find the value of the constant k for which the equation g if x equals 0 has 2 equal roots. Okay, so anytime they tell you how many roots there are, you're always going to be using the discriminant. So just make sure that you know that because you need that to do this question. Now g if x, g of f of x. So that's when you put fx into g. So our fx is, let's just write it down again so we have it here. Fx equals 2x minus 3 squared minus 11. That's our fx. So g if x equals, so we're putting fx into this x here. So 2 bracket 2x minus 3 minus 11 plus k. I always forget the squared. So this part here is fx. Okay, so now that we've got that, let's expand it, simplify it. So we've got 4x minus 3 squared minus 22 plus k. I'm going to expand it some more. So 4x squared minus 6x plus 9 minus 22 plus k equals 4x squared minus 24x plus 36 minus 22 plus k. 4x squared minus 24x. 36 minus 22 is 14 plus k. Okay, so now that we've got it in this format, we're going to find the discriminant. And if it's 2 equal roots, that means d equals 0. So just keeping that in mind. d equals b squared minus 4ac. b squared, b is negative 24, so we can just write 24 because we're squaring it anyway. 24 squared minus 4 times a, which is 4, times c, which is 14 plus k. So there's our discriminant. Now let's simplify it. 24 squared, 576, minus 16, 14 plus k. Is equal to 576 minus 16 times 14. Typing on the calculator is 224 minus 16k. And in the simplest form, this is 352 minus 16k equals 0. So we're writing equals 0 because we know that it has 2 equal roots, which means the discriminant equals 0. So that means that 16k equals 352, and k equals 352 over 16, which is 22. So k equals 22, and that's our answer. So that was question 9. Okay, last question, guys. Let's get through this. So we've got a parallelogram, we've got vectors. So part I says find the unit vector in the direction OB. Okay. So one way to get there is by going OA plus OC. So that's what we're going to do. So for part I, we're going to do OB equals OA plus OC. And what is OA? We know that OA is 1, 3, 3. 1, 3, 3 plus OC, which is 3 minus 1, 1. 3 minus 1, 1. Now we're just adding across, so that'll be 4, 2, and 3 plus 1 is 4. 4, 2, 4. So that's OB, but since we want the unit vector, that means that the magnitude has to be 1. Now the magnitude of this vector is probably more than 1. To find the magnitude, we do this. OB equals, and you put a square root sign, you square all the elements inside it and add them together. So 4 squared plus 2 squared plus 4 squared, which is equal to square root 16 plus 4 plus 16 is 36 square root. So that's equal to 36, root 36, which is 6. So to find the unit vector OB, it will just be, you just have to divide all the elements inside by the magnitude. So that'll be 4 over 6, 2 over 6, and 4 over 6, which we can then simplify to 2 over 3, 1 over 3, and 2 over 3 again. And that's the unit vector for OB. So that's part 1 done. The acute angle, so part 2 says to find the acute angle between the diagonals of the parallelogram. So here's our parallelogram, here's one of the diagonals, here's the other diagonal, and we want acute angle, which means the smaller angle, so this one. So for this, we are going to use the formula cos theta equals A dot B over magnitude of A and magnitude of B. So this theta is the angle that we're talking about, and A and B are the two vectors involved. So we already have OB, we already have the vector for OB. Let's find the vector for AC. Let's find this vector. So AC equals, so AC is going to be, you go this way and then you go this way. So this is plus OC and minus OA. So AC equals OC minus OA. OC is 3 minus 1, 1, and OA is 1, 3, 3. So this is going to be 3 minus 1 is 2, minus 1 minus 3 is minus 4, and 1 minus 3 is minus 2. So we can just simplify that to 1 minus 2 and minus 1. So now that we've got AC and we've got OB over here, we can use both of those in this formula. So let's move this out of the way. Okay. So cos, let me just use a different color. Cos theta equals AC dot OB over magnitude of AC and magnitude of OB. So cos theta equals, so this is the dot product. So we're going to write AC down minus 1, okay, dot, and OB is 424. I'm going to simplify that a little bit and write 212 over the magnitude. So the magnitude of AC is going to be the square of these things added up. So 1 squared is 1 plus 4 is 5 plus 1 is 6. 6 times root 4 plus 4 plus 1, so 9. So this is 3. So this is cool. Okay. So how do we do the dot product? The dot product is just this times this plus this times this plus this times this. Sorry, my highlight is really big. You probably can't tell what I'm highlighting. Let me make it smaller. The dot product is going to be 1 times 2 plus minus 2 times 1 plus minus 1 times 2. So that's how you do the dot product. Okay. So 1 times 2 is 2 plus minus 2 over 3 root 6. So this is just minus 2 over 3 root 6. And we need to find the cos inverse of this, because this is cos theta equals this. So theta equals cos inverse 2 over 3 root 6. Divided by, I'm typing it into the calculator. And for this, make sure that your calculator is set to degrees. So I've got 74 degrees. 74.2 degrees. And you always do it to 1 decimal place when you're doing degrees. Alrighty. So that is that. And we know that this is the angle we want because it's acute. If we got something bigger than 90, then we would have to do 180 minus that. But in this case, we already got an acute angle, so we can just leave it as is. Okay, so that was part 2. Now we want to find the perimeter of the parallelogram. Correct to 1 decimal place. So the perimeter of the parallelogram is just going to be the magnitudes added up. So we know the magnitude of OA. Okay. So it's just going to be a magnitude. You know what, I'm just going to copy this diagram down. Okay, so for part 3, we're going to find the perimeter of the parallelogram, which means we have to find the length of this, and 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 add them all up. which shouldn't be too hard. We actually already know the magnitudes. So the magnitude of OA, we just use the vector, so OA is equal to 1, 3, 3. So magnitude of OA is going to be square root 1 squared plus 3 squared plus 3 squared, which is going to be 9 plus 9 is 18 plus 1 is 19. So square root 19. That's the magnitude of OA. So this length is square root 19, which is the same as this. Now OC's magnitude, OC is 3 minus 1, 1. So magnitude OC is going to be square root 3 squared plus 1 squared plus 1 squared, which is 9 plus 1 plus 1, which is 11. So root 11. So we've got root 11 here and root 11 here. Now we just have to add all of these up. So perimeter equals 2 root 19 plus 2 root 11. And they want it correct to 1 decimal place, so you type it into the calculator. 2 root 19. And the answer I get is 15.351. So I'm going to round that to 1 decimal place, and 15.4 is going to be the answer. And I write 1 dp here to let them know that I've rounded it. So there you go, question 10. And now we're done with the paper. If this video helped you, give it a like. If you have any questions, if you want me to go over anything in more detail, just leave a comment down below and follow for more.